What does manufacturing mean to, well, everyone? It's the heartbeat of America. It's the creativity that makes all the things around us. If it's not people and if it's not air, take a look around. It's been touched by manufacturing. But a lot of us have forgotten about where it all comes from. Well, I'm in Windsor, Vermont today at the American Precision Museum, and I have the wonderful opportunity to show you the insides of a historical landmark from 1846. Yes, we're gonna step inside and talk with several of my friends, Dave, Steve, Molly, Jerry, Joe, a whole team of people, and we invite you in to learn a bit more about how it all started. Dave, how we doing,
Tony,
my friend?
thanks so much for being here, man.
Absolutely.
Really appreciate it. Welcome to the American Precision Museum. We're so happy to have you here.
American Precision Museum. You know, I gotta be honest, I'm really happy to be here, but I didn't know about it till you guys gave me a call, and today we get to share this with the whole world, so thank you for that.
Well, what you're gonna hear today and experience is the origin story of the American system of manufacturing.
The origin, everyone loves a good origin story,
exactly,
right?
Of course. Right?
Whether it's X-Men and Marvel or something like this, which probably created the X-Men and Marvel, right? You think about that as well.
Okay.
Precision, guys, the museum. I mean, we're bringing it all together here in Vermont. Let's start to take a little walk, Dave. As we look around here, I'm seeing some beautiful art.
Yeah, we have the exhibitions here ongoing. Right now we have this photographic exhibition, and we bring artists in and they make machines look artistic.
And this is the lobby area. Yes. We're gonna get into the precision world, but this is where you do the meet and greet.
Exactly.
There's a video going on behind us as well.
We've got our gift shop over here. And Tony, I want to point this out over here.
Oh, this looks beautiful.
This is our sponsor wall. But the reason I'm pointing it out is you'll notice these are all manufacturing companies. These are manufacturing companies that realize that we are the keeper of their history. And they, in turn, help sponsor us and keep us going.
The keeper of their history. Dude, I don't know if you could have said it better than that. That's incredible. I would like to say while we're here, if I could just invite the audience and the camera person, take a close look at this, and let's thank all of these sponsors for preserving something that's of the utmost importance. On top of that, Dave, are you looking for additional sponsors?
Absolutely, all the time, yeah. We want to get the word out.
Yeah, so for everyone listening and watching right now, if you wish to donate, if you wish to become a sponsor, I mean, why not preserve history? As you said it best, the preservers of history. And this is a nice little area too. Am I gonna get to leave with a gift or two?
Of course, of course.
I'm definitely gonna pay for it. Don't worry, don't worry.
Well, Tony, let's go on in and check out this history we've been talking about. I'm fairly new to the museum. I've been here for about a month. And I came here to help them get to a new level in terms of visitorship, in terms of what we have to offer, in terms of services, and what more of the educational piece that we can spread the word. And so I'm the fundraiser. And I came to the museum because I have a personal connection here. My family had a tool and die company out in Indiana, little company. My mom and dad were both on the board, and then my dad was a mechanical engineer. So I grew up going to ASME workshops and events and things like that, and so it's in my blood. And when I was raising my kids, I have two kids at home. I homeschooled for them for a while, and we come here with the kids, and I wanted to learn about manufacturing and what that meant in that world. And I think it's important. It's incredibly important. And I want to share that same experience with other children, with other adults, and make sure that they are getting the picture, the story that is being told here. And it's an origin story. The story of how the American system of manufacture started. And I want to help spread that word. This museum offers a story. And actually it's many stories. And those stories are being shared here. about the American system of manufacturing. And that history is incredibly important to our town, to our region, to our country. And from here, it's spread. It's spread to other countries. It's spread up and down the Precision Valley. And that's the story we're telling here. And I want people to hear that story. So when I first came to the museum, which was not that long ago, I was so incredibly impressed with the corporate sponsors that the American Precision Museum has that help fund what goes on here. And that's so incredibly important to continue our good work here and to keep spreading that story, keep spreading the history. And I love that they understand that we are the keeper of their history. And the fact that they are giving back to us and that we can then share that with others is incredibly important and heartwarming. And I'm going to leave you here with our executive director here at the museum, Steve Dalessio, and he's going to help you learn about manufacturing and where it started.
You are amazing, Dave. Thank you so much. Steve, it's so good to see you.
How you doing, Tony? Good.
Happy
Good.
and grateful. I'm so excited to be here.
Yeah.
And as I look around, I mean, I'm seeing a lot of black and white pictures here. So we're starting at the beginning, aren't we?
You got it. 1846 products are made by hand. So we start our story right from the beginning. Right
Made by hand, beautiful on the wall. I mean, let's look at some of this, Steve. I mean,
Yeah.
let's show the audience kind of really is the made by hand craftsmanship from the beginning of manufacturing.
You got it. And, you know, I think a lot of our audience, their grandparents may have some of these tools still sitting in their toolboxes. But yep, we start the story from products being made by hand and each one being unique.
It is unique. How many of those can you use?
Every one.
Can you?
Yes.
How many of those can you use? Please leave it in the comments. I want to know that as well. So, from my understanding, there's these three main guys here that kind of started this whole thing
Absolutely.
off. But before we get into that, why this area, Steve? Why what I feel like to be a long way from a coastline
Yes.
in a place that was once considered the Silicon Valley
Right.
of precision manufacturing, right?
Right.
How did we get here in Vermont?
Well, this area is, you know, the north was always the industrial area, and it started up here. There was a lot of resources, natural resources. There was water power from the rivers. There was lots of trees for logging, and there was just lots of industry up in this area.
That does make sense, doesn't it?
Yes.
And we're grateful to have the water because we're getting ready to look at some of these tools. This entire place was run off of the beginning of hydropower, right?
Right, water power. That's what this whole Precision Valley was all about. So factories grew up all along the Connecticut River, and that's how it all started.
Wow. I love the craftsmanship of the hand, and we start to get into the world of machines as well. Do you want to briefly go over these three young men?
Yep. Lawrence and Kendall were gunsmiths right here in Windsor, Vermont. They were just manufacturing, practicing gunsmithing by hand. Along comes a third gentleman, Samuel Robbins, and Samuel Robbins is a young entrepreneur. He made a lot of money logging in Maine. As I said before, this area is rich in timber. And he came along and there was a bid for 10,000 guns for the U.S. government. And he said to Lawrence and Kendall, if you guys can do it, I'll back you financially. And they said, sure, why not? But there was a clause, and it was all about precision, repeatable manufacturing or interchangeable parts.
10,000 guns.
10,000 guns, $10.90 a gun. And they won it by 10 cents a gun.
We've kind of had some price changes since then.
Yeah, right, exactly. But but as all good manufacturers, we like to bid on jobs and then say, okay, now we got to do it.
Speaking of that, I'm so happy you brought that up, Steve. How many of us out there are doing that? You bid on a job and go, okay, now what?
Now what am I going to do?
So getting on trying to make it work, we're now going through an era of innovation, aren't we?
Right, exactly. So we have this water wheel here to power the building.
You're talking about this wheel or a simulation of the wheel.
Right.
If we look around here, actually powered 3 floors of building?
Of this whole building, yep. One floor was just draftsmen, so it didn't need to be powered, but the other floors were carpentry shops and metalworking shops and so forth.
I mean, When I think about the pulley system to begin with, and I think about modern times, how many of you are thinking about this as well? Modern times, the amount of speed, RPM, the amount of horsepower and torque we need, at that time, they were trying to balance the mathematical equations of ropes and pulleys to power things. If we turn over here, if we look, the machine is running from Steve turning it right now. And this was all through water, through hydropower, right?
Yeah, exactly. The whole building was done with water power. And this machine, just like as a horizontal spindle, running a form tool, because we transitioned from products made by hand to products now made by machine.
I'm just going to try to envision something theoretically, right? If I'm a guy who's making precision products by hand, and then I first see this machine, do you think I'm excited, shocked, concerned, worried? What do I feel, do you think, when I'm seeing this for the first time?
I think at first they were probably worried.
I think I would be too.
Because that's typical of what people expect today from automation, right? They worry about it. But what it did is it opened up new jobs.
Yes.
And that's what was really going on here. Now that same person that may have been in front of a part filing it is now in front of the machine. So I don't think jobs were lost. I think they were just rearranged a bit as well.
Steve, I want to give you a hug. You want to know why I want to give you a hug? It's because for the people watching right now, we're also dealing with that currently.
Same
the
issue.
Automation, the AI, this 3D printed, additive manufacturing, we're thinking we're going to lose jobs. It's not.
It's about just reassigning them and doing different things.
Yeah, exactly right. And speaking of reassigning and doing, what in the world is this,
This
Steve?
is one of my favorite machines in the whole
How
museum.
How could it not be?
Yeah, it's what they call an inletting machine. We may know it as a follow router or a pin router today. If you're a woodworker, you may have used it as a pin router. Here they stacked up different patterns and a probe would follow the pattern and the cutter going along for the ride. When it was done with one operation, it went up to an idling position and the operator would index the whole machine and bring in another probe and another cutter. First example of tool changing that we see.
So this had more or less 5 areas where you could mount
spindles.
tools, 5 different spindles.
Yep.
This is the first tool change.
Pretty close.
This is the first tool change.
It's pretty close.
And what is this coming up here,
you know,
Steve?
you wouldn't want your operator to get all those wood chips on you, so they built in bellows to blow the chips away.
This is air blast.
Air blast.
The first air blast.
Right.
I mean,
all run from one belt off of the pulley system that you see in the ceiling. Down.
Yeah, look around. Oh, let's take the camera and show the system that's all through the ceiling right now as well.
Yep.
And this is original, more
These
or
are
less?
Original, more or less. Yep.
Wow, and we're talking 1846.
1846, and there's the wooden pulley in that corner as well.
That's fascinating.
Yes.
I don't know if people get as fascinated by this kind of stuff as you and I, Steve, but I love it.
Yeah, I'm all into it completely.
Are we nerding out a little bit? I know I am.
It always happens, but that's okay. I could talk about manufacturing forever.
And we might, but we can't make this video too long, but we might. So this looks like an interesting machine as well.
Yes, this is it was designed by Thomas Blanchard, no relation to Blanchard grinders, but it was for turning irregular shapes. As we know, lathes typically turn round stock or hex stock back then, but this one turns an irregular shape like the butt of a rifle or the gun stock of a rifle. Same problem, same issue. They used a follower to follow the steel pattern. While that was going on, the cutter was moving forward to the wood, cutting the wood stock. We think it was able to, by hand, it would take about 12 hours to carve this. And by this machine, it was doing maybe 10 or 12 per hour.
Steve, this is something I want to discuss, but I'm going to have my camera guy point at this area here because the precision that went on 100 plus, almost 200 years ago, the precision was close. I mean, it was there, right?
It was there.
It's really about time, isn't it?
Right. So we were trying to create things for more affordable for people at the time. So the only way you can do that, just like today, right? Time is money. We try to reduce the cost of our processes by reducing the time. So here, a gun made by hand would take about 115 hours. Through this new process that these guys created, was now taking about 31 hours.
Steve, what I want to do real quick for everyone watching out there, when we talk about bidding on a job, when we talk about being able to become profitable and being efficient from a job, apparently we've always been trying to make that happen, right? When you're talking about bidding on $10 per gun, was it $10?
$10.90 a gun.
And 90 cents per gun, and then they had to figure it out.
It's amazing.
Could you imagine $10.90 at 115 hours versus 31? There's a big difference between those two things.
You got it. That was the whole objective. And also, again, part accuracy improved.
God.
So now they had reliable, as I mentioned before, guns were breaking and stacking up, waiting for gunsmiths to come along to hand fabricate another part. Now they have the replacement part there as well.
Steve, I want to talk about something else, and that's this wall right here before we slide into something from 1951 that's really fascinating to me. But this wall right here, you touched on it briefly about being able to make goods more affordable, more cost effectively, right?
Sure.
You mentioned that. About around this time in the mid-1800s, clocks, not everyone had one.
Right.
Bicycles were extremely expensive, right? And we're going to get into this a little bit further down the tour, but that was a big deal. This whole hand-to-machine thing really changed the way people were doing things, right?
That's correct, right. It was only, we had to reduce the cost, right, for the average person to be able to afford it. So they did it through automation. They did it by pattern tracing. And of course, as you talk through the museum, you'll see how that morphs again into what we call computer numerical control. So the benefits, the factories, best place to work. It created good jobs for people. It created community because these factories were holding picnics and concerts for families. They were taking care of their people. They created new types of jobs. Suddenly there was need for shipping personnel, purchasing people. HR became benefits and things like that became popular as well within the factory communities. They brought new businesses, right? We always talk about a big factory. There was always a barber nearby, right? So we created this other business, this new economy for other people as well. So it's so important to have factories.
And let's think about all that. That's happening today as well. Not,
That's right.
We both say it was so important, but it is so important.
Exactly.
We might be walking through the history right now, but history is now today as well.
Right.
History is the now.
That's why it's so important today for us to be able to inspire a new generation on the backdrop of history, right? They need to understand where we came from and how it applies to today. And that's what we're trying to do here. Manufacturing as a whole means to me good paying jobs, good opportunities, innovation, invention. What inspires me to be part of the American Precision Museum is that I'm all about manufacturing. I started sweeping floors at 10 or 12 years old in a screw machine shop right near my house. I was a tool and die maker apprentice, realized I was not going to be very good at it. So I went off to college to be a manufacturing engineer. I spent 25 years in medical device, which really I thought was great because it was helping people and doctors make medical decisions on products that I was involved in. Then I came to New Hampshire to chase my entrepreneurial spirit with a small job shop and grew it from a manual company to a full CNC company. And then I became chair of the board here, the American Precision Museum. And winding out my career, I felt it was important to give back some of my experience to preserving history of manufacturing. If we don't connect to the next generation of whether they're manufacturers or innovators or inventors, the U.S. economy is just going to be in so much trouble. We need that core to be able to produce product for the masses, produce product for military use. The next generation will be think about all the great things that are going on with AI and automation and all those things. And the next generation is what's going to make all that happen as we move forward here. So what really excites me about being in manufacturing all my career, it's provided me with great opportunities. I've saw lots of parts of the world that I wouldn't have ever been able to see if it wasn't for my job in manufacturing. But what really excites me is that I do a talk with young people once in a while that says, what do I like to do? And I tell them to close their eyes for a moment and look around you when you open them. Everything that you see had to be made by somebody, somewhere, by some process. And it doesn't matter whether it's hard goods, machining parts, whether it's cooking, it's all about manufacturing. It's all about creating something from nothing or from raw materials. And that's what excited me at a very early age, that everything I was doing had to be made by somebody somewhere. here.
Thank you for dedicating yourself to that, Steve. You have been an absolute joy. I hope we get to see you again.
Yes.
In the meantime, I'm going to go talk with your colleague, Molly, who I absolutely adore. Molly, we're going to now jump into around the 1951 era, which is one of your favorite times and platforms to discuss, isn't it?
Yes, so the 1851 was a really important year for the American Precision Museum. Robinson Lawrence had been selected by the U.S. government to represent the arming world in the Great London Exhibition led by Queen Victoria and Prince Albert. So the royal family in England had gotten together to put together a huge exhibition of everything that the world had to offer, all the great advances in art, manufacturing, culture, music, and Robinson Lawrence got to be a part of that. So they brought 6 of their 1841 rifles, the ones that they had done such a good job with here, and they broke them down into each of their individual parts, putting them in separate baskets. And when the judges came, the workers from here put them together at a random order because to show that there was true interchangeability with all of the pieces. The English were amazed and delighted, and they put in an order for 10,000 rifles.
Another 10,000.
Another 10,000. But the most important thing was they wanted the machines because they recognized that what they called the American system of manufacturing was the system of manufacturing that was going to launch the whole world of manufacturing forward, not just for armament. And so that changed. That really is how we do it. Having precision machine tools shape the whole course of manufacturing, and it all started right here in the American Precision Museum and the Robinson Lawrence Armory. So in 1851, Queen Victoria and Prince Albert looked at each other and said, "Do you know what I think would be fantastic? Let's have a magnificent party to celebrate all the wonderful things the world has to offer." And so they started the Crystal Palace exhibit. So Prince Albert turned to his friend and said, "I say, we need a splendid building for this." So they hired a gentleman named Joseph Paxton, and he said, "Do you know what? Let's build something magnificent, and we'll do that with a new cast iron modular system, which includes fresh glass straight from the glaziers, because you see, they had recently developed the process for making rolled glass as opposed to blown glass. And so he was able to take glasswork straight from the glaziers and pop them into a modular glass system and use that to build the Crystal Palace. He did it in 6 months with a fairly small number of laborers, and that was how we got the Crystal Palace.
That's absolutely fascinating to me. And now I have a couple of other questions. Can we dive in a little bit?
Fantastic. Let's go for it.
The first one is, in order to have interchangeable parts like that, we have to have precision and the redundancy of making that same part over and over again, don't we? And this is 1851?
This is 1851.
I mean, that blows my mind in itself. Secondly, another 10,000 guns means they had to be really high caliber, because if I'm looking here, we got India, Persia. I mean, it's just a made-up portrait here, but the whole world came together. Is that true?
They really did. And actually, this is the etching here is an etching of the actual inauguration ceremony for this whole exhibit.
Wow.
And what's fascinating is, this is something I find fascinating, I found the original floor maps for the whole Crystal Palace exhibit, and you can see the actual labels of all of the sculptures in it. So this is a fairly accurate representation of what was there. So, but yes, they did get 10,000, an order for 10,000 rifles. And so this one here, this long one, was the Enfield pattern 1853 that they made for the English. And you can actually see the crown on the lock plate, because this was an armament made for the British Army.
Oh, you can see it right there. Yeah, that's okay. The last question I have for this area, which I also think is kind of neat when we think American system of manufacturing. Although another 10,000 guns were made, this was kind of the beginning of machine tool manufacturing as well, right? Because it was the technology of how it's done that was even more revered than the product itself, wasn't it?
Right, exactly. So that American system of manufacturing really did shape the entire course of history, because it let the whole world have the access to a series of machine tools that would create that kind of interchangeability that you need for any product, whether it be guns or consumer goods.
So what Molly is saying, as we walked back through with Steve and Molly, we're going to take a look at this wall over here, but when we walked through with Steve, a lot of those machines were innovative, right? They were either taking something existing and molding it to what they needed, or completely structuring something new to create a type of technology that hadn't been done before. And that's kind of the evolution of what England was so excited about, right?
They really were excited. And so Robbins and Lawrence, they fit into a larger picture of history, especially up and down the Connecticut River Valley. So there was a lot of manufacturing that was being developed, and a lot of people that were pushing against the bounds of what was possible in precision manufacturing. And so the Connecticut River Valley was hugely fertile in that manufacturing sector. And we were sort of the northmost post for it. Springfield, Vermont was hugely important, as was Bellows Falls, all the way down through Massachusetts and into Connecticut. And so these are still industrial sectors today. Unfortunately, Robbins and Lawrence, they eventually did go out of business, but what started here launched so much of the manufacturing world that will never fully be changed because of how great it was.
It truly does, Molly, like, intrigue me that it was here, the beginning, the growth, precision manufacturing. And we're also talking about World War I, World War II era as well, where these things were just of the, again, utmost importance.
Yeah, well, as we've said, the ability to arm a nation is hugely important for
kind of a big deal, right?
World. And the globalization of the world that followed World War II was in large part possible because of the manufacturing that was so strong in the United States.
You know, something that stuck with me that has been said previously is the Silicon Valley at that time, right, was this Precision Valley, as we see right here. Precision Valley was here, Silicon Valley was here, and there were just so many people learning the trade in this area that just went off and kind of did their own thing, a lot of entrepreneurism, but the precision was started here, wasn't it?
It really was, and Robbins and Lawrence started a mindset that was very innovative and very good at pushing forward against the, as I said, the limits of what's possible. And so we have a family tree of sorts of people that started here in Robbins and Lawrence and then went on to do things like J&L, Bryant, Fellows Gear Shaper down in Bellows Falls, and then they spawned their own companies of like-minded men and women who were so good at creating new innovations on the backdrop of what had been done right here in this building. I think what manufacturing means to me is the ability to have more access to new consumer goods and more access to things that improve quality of life, because I get to have a refrigerator in my house rather than having to bring in blocks of ice that have been cut out of the mountains somewhere. And incredible access to modern healthcare. So I don't have to go to someone who's going to, drain blood and prescribe leeches for various ailments, but top of the line, incredible advances in medical technology. And so having that kind of access to a global economy where everybody's lives are improved by access to better jobs and better quality of living through the advances in manufacturing is something that's really important to me. So for women in manufacturing, it's an incredible opportunity for women to be part of an industry that requires a great deal of skill and innovation and mental acuity, as well as the physical dexterities that we all have by just being human. And the advances in manufacturing have improved life and the processes where you don't have to be maybe as physically strong as men, because the whole process, especially of automation, means that the manufacturing world isn't as back-breakingly physical as it used to be. So manufacturing now is incredibly safe, incredibly valuable, and it means that it opens up a world to everyone, especially women, to use their gifts of math, science, innovation to solve problems for everyone, because I think women are especially good at recognizing problems and fixing them. And the whole world of manufacturing and innovation is finding problems and fixing them. It's always really exciting to bring kids to the museum because they're so curious and so excited to learn about the history of this place and also how they have the toys and games that they have and the world of exploration in front of them. I ask kids a lot what they want to be when they grow up, and many of them say things like YouTuber or influencer. And the kids only have that kind of perspective in life because they have the internet at their fingertips and incredible gadgets in their pockets that have more computing power than we sent to the moon. And so What we get to do here is advocate for a whole world of innovation, of making, of curiosity that these kids get to explore. And the funniest thing, though, is that while they're excited about the future, they're also excited about the past. We've done work creating demonstrations and various activities up in the museum, but the thing they enjoy the most is getting onto an original typewriter and pounding away on those keys. Without manufacturing, this world looks like a very dark place that has very limited insular communities that requires more work, more backbreaking work, and limits the scope of future and opportunities. So our world is incredibly connected with incredible opportunities for people from all over the world to go and see what we have at our fingertips because of our global economy and the manufacturing sector. And without the manufacturing sector, we open up a dark world of people that can't travel, that can't explore. Their opportunities for work require them to limit their activities to backbreaking sustenance farming rather than getting to explore the world of art and creativity and pleasure and music that we have because we have the manufacturing sector to support that. And without it, we have to scrape by a living that's dark, dirty, and dangerous.
That's very, very cool. Molly, thank you so much for your
Thank
time.
you.
I absolutely appreciate you. I'm going to go say hi to Jerry now, but as we do that, look at these two Bridgeports. And guess what? I got the secret knowledge that you guys are about to learn as well. I was going to say don't know, but you're about to learn it, which is this is Bridgeport number 1. And you know what's better than Bridgeport number 1? Bridgeport number 0. Yeah, this one was actually taken out of the factory and put into the gentleman who I believe invented it, created it, built it, started it, somewhere in that area. But this doesn't actually have a serial number at all. So 1 and 0. Now that, and they're letting the kids play with it. There's a magic marker on here. How they let the kids play with it? With that being said, let's go say hi to my friend Jerry, and we're going to step forward a little bit in time, but not too far because, well, we love to see the evolution of technology. We want to connect with everyone out there so you can see the beginning and how it's affecting your lives now and how important manufacturing is as a whole as we continue to hopefully expand the awareness of manufacturing. Jerry is a key man in that advocacy as well, so I'm honored to be here with Jerry. Jerry, it's good to see you, brother.
Pleasure to see you, my man.
Thanks for having us in. Really do appreciate it. So we're now in the science of measurement, and we're going to walk around kind of what evolved from that beginning of precision, that beginning of the machine tool creation, right? And what started to be made.
Right. So obviously we talked about already, you've talked to people about the precision and the accuracy. Well, in order to ensure the accuracy, you got to be able to measure what you're making, right? Our measuring folks out there are going to love this part, all of our CMM folks out there. Many a manager in my day in the shop would say you got to inspect what you expect. And,
I like
so
that.
this is a table, a display, and it's a pretty expensive table because it's really a lathe, and we'll tell you about that later, but we're really trying to show various forms of measurement, and some of them are quite old, but this one here tells you how to calculate the speed of a ballistic item, a bullet, right?
Okay.
So using time and distance, you would have a long rod held by electromechanical means. You have the short rod, and you drop the bullet, and this unit would tell you, based on the mark that was left, the speed of that bullet using the calculation of time and distance.
You know, when I was a teenager, I thought math was stupid. As an adult, math is so cool.
Math is really cool.
Yeah.
Clock, you're wondering about that. We're thinking about today.
Jerry, I'm going to interrupt you.
Oh.
Why does that say 8-day clock?
This clock was made for whatever reason that it only needed to be wound once every 8 days. Initially, a lot of the clocks had to be wound once a week. We don't know for sure if it was to avoid winding it on the Sabbath or what, but this clock, unlike most, only needed to be wound once every 8 days. So that's why it's called that. The fascinating thing to me was, as much as we're uptight about time today, in the 1700s, only 1 in 50 households even had a clock. And they weren't even mass produced until the early 1900s. So that's the other reason why that's there. It's a reminder of how far we've come in not that long a distance.
How are we telling time? Was it the sun?
I think so. Most people didn't have all the appointments we have today, but they look and say, okay, that's sometime afternoon. Maybe we should go eat. And that's, look, if the sun's low in the sky, let's go have dinner. It's different.
You know what I think of when I see an 8-day clock?
What's that?
I think of the Beatles saying how much they love us.
There
That's
go,
8 days a week. That's right.
Yeah. And in manufacturing, some days that's what it feels like.
Sometimes we work 8 days a week.
Yeah.
So this looks like a canteen. Like I'm gonna drink some water or some whiskey out of it.
So interestingly enough, trust has not always been a part of our philosophy and our world. This is a watchman's clock. Every door that he went to check to make sure it was secured had a key. And so the watchman would insert the key, turn it, and it would timestamp that so the owner would know that the security guard wasn't napping or he was doing his job to make sure the buildings were secure.
So that hasn't changed a whole lot in modern times, has it?
It's heavy. Imagine wearing that around all night.
So it could lift weights. I could get some muscles this way.
You could do that.
Now, I want to keep sliding down here, but I don't want to slide too far without asking you what this set here is about. I don't want to lose the opportunity to talk about this.
Yeah, so Henry Ford, mostly if you recognize that name, he was a friend of Carl Johansson, or he really admired him. Johansson was the inventor of what we know as the Joe Block, a very precision instrument. This particular set is a complete set, which is in itself unusual.
That is, yeah. I lost mine all the time when I was doing measuring.
Ford and Edison were very close. So Thomas Edison was gifted this set of Joe Blocks by Henry Ford, and they were here at the museum as a gift and display. And Edison, actually, there's a signature on the back side of the box. But
okay, as we slide back over here, I have to ask, how the heck did you guys get that? And serial number 1 and 0. I mean, what are you guys doing here?
It's a good question. Part of what we're trying to do is preserve history, but in doing so, we also want to educate people on the difference the American system of manufacturing made in the lives of people. And in doing so, do it in a way that inspires young people of all ages, because it's not just the youth that need to understand about manufacturing. So we're trying to get the word out, Tony, that this stuff is not only cool, it made a difference and continues to make a difference in people's lives. And we'll talk about that a little bit further on.
I mean, you had mentioned already 1 in 50 households had a clock. We knew bicycles were expensive. We do get into consumer culture before too much longer. And as we walk through, maybe we don't need to touch on all this, but we do want to let because we want to leave some secrecy for people to come see you as well, right? But let's talk about pi real quick. You called it pi because it's 3 letters that help you
it's easier to remember.
It is easier to remember. So this museum focuses on 3 main attributes to connect with people watching. Would you mind just quickly going over those?
Yeah. So preservation. It's important for us to both honor and preserve these items and the history and the story behind them, and the importance not only to the day, but that they made in the lives of people. In doing so, we want to educate them, so we switch the letters around a little bit, and in educating them about history and how we learn from that and the innovations that took place and how they changed people, we're hoping to tell the stories in such a compelling way that we inspire people to seek out and learn more about manufacturing. And if it's not born, hatched, grown, or mined, it's made, it's manufactured. So we're a big part of the world and what's happening, but people don't understand that because a lot of people aren't exposed to it. So that's what we're trying to do.
We are too, my friend. A lot of us are. So speaking of inspiration, is there anything else on this table you'd like to bring up before we slide into the giant
2 things real quickly. Yeah, the expensive table that's really
the expensive table.
This was built in 1878 by Brown and Sharp, right up the road in Providence, Rhode Island. It is a super micrometer that was tested in the 1900s, 1920s, and still can measure down to 1/1,000,000th of an inch.
No, it can't.
Yeah.
Are you serious?
Yeah, I don't have a way to prove that to you, but to 1/1,000,000th of an inch, and it was built 170 years ago.
Come to the museum and check it out for yourself.
There you go. If you don't believe it.
Prove Jerry wrong.
Rockwell hardness tester, which is the theory and principle is exactly the same as it is today, used to test the hardness of a material. So this is quite an old machine here.
And this one is hardness tester as well, right?
Exactly.
It's kind of bounced the ball off.
Yeah, Steve likes to tell you that if you drop a golf ball in sand, there's a thud. You drop it on concrete, it bounces back up. So you tested the hardness of a material based on the rebound of whatever you were dropping.
Creative.
Yeah.
Measuring hardness, kind of important if you're running machines off of water. and hydropower. So now we get to this really expensive display table that everything's been on, which is actually a lathe bed.
Built in this building in 1867 by Windsor Manufacturing. This thing is a single piece casting, so I haven't checked it, but it looks like it's about 18, 20 feet long. There's a riser in here, and so we surmised that perhaps they used it for the line shafts and put the pulleys on the line shafts between centers to true them up for the various machines that were running off the belt and pulley system.
I don't know about you, Jerry, but I get like chills when I try to think about how this stuff is done. Let's continue to walk and talk a little bit. I look to my left and right, I see some additives, but we're gonna jump at that at the end of this tour as well. So as we're walking through here, Jerry, what are some of your favorite parts about being here? Like working here, spending time here, the people who donate, and the inspiration that you get to drive into the community around, especially in manufacturing.
Well, I'm inspired because, in a lot of ways, but mainly because I cut my teeth in the manufacturing arena. My dad encouraged me to be an apprentice, a machinist apprentice, and I told him, Dad, I don't want to run a machine my whole life because that's why you want to be in this program. So I have ground my own high-speed steel tool bits. I've run a lot of manual machines, including planers and shapers, and I wouldn't recommend it, but when I was on second shift, I got on a shaper and rode that thing one time.
Still got all your fingers and
I got all my
fingers. Thank goodness.
But it brings back a lot of memories because, and I think of the engineering and the minds that created some of these things in design and what it went through, what they went through to do it, and how they made them with what they had available at the time. A lot of these machines here, like that large shaper, that was probably a size that wasn't used to make firearms. That was probably other components for machines. And so in this building, it wasn't just about that American system of manufacturing or just about firearms. It was about machine tools, innovation, creativity, and changing the lives of people through making things in an affordable way. So
it's almost like you've said that before, Jerry. That was good stuff. Before we disappear from this section, there's two things I want to point out. One, we don't know what the heck that is, first of all. So if you guys that are watching this, leave comments. This actually says mystery machine. Have fun, be curious, and explore. The machine was a gift to the museum staff. So yeah, let us know. Absolutely. The second thing is, it looks like we have a Mastercam and Haas project over here. That's kind of a replica of how this was originally done. Is that correct?
Yes. You'll notice that these aluminum gear teeth are in segments, and that is because back in the day they didn't have a machine, a gear cutter, big enough to do an 18-foot diameter gear. So the actual original gear was made in segments, and you see an old segment here from the 1800s. It's pretty heavy, or we would lift it up. Tony probably works out more than me, so I would not be able to do it. But our friends at Mastercam and Haas went together, took the original design and put this together so that we could have a functional replica here for people to look at and
Thank
see.
you for doing that, guys. We appreciate it, absolutely. All right, I know we're getting to a part that you absolutely love to talk about, and that's consumer culture. As we do that, I'm also seeing, I think this is a milling machine here of sorts.
Yes.
This is some sort of
planer to make flat pieces.
I mean, every single piece here, I don't know if I'm as nerdy as the people that are watching, maybe less nerdy, I don't know, but I get excited when I see this kind of stuff.
I do too, and we can't display everything because we have limited space and everything isn't under power, but it really is fascinating to see this example of an old turret lathe, 1861, right? So that's the beginning of the Civil War period. There's a turret lathe with multiple places to put, so you could run at different RPMs. You change where the pulley, the belt is on this to change the speeds. It's just amazing to me.
It is. And now I kind of want to try and bring this all, it won't be full circle because there's more of this tour to come, but it does bring us to a point of how can we connect with the people watching right now. Those of us who are in manufacturing watching right now, they get it, they love it, they know the difference. We've already talked about, you know, if it's not the air and us, everything else has been touched by manufacturing, but there is a tangible place where we can go, oh, this is the evolution. So let's talk about the consumer side of things, Jerry.
Yeah, so there's two pieces to that. One is, at some point, after 1865, there wasn't the greatest need for a lot of firearms, not like there were during the Mexican-American War and in the Civil War. But the other piece is there were a lot of people, many of which started here, and I think Molly told you a little bit about that, that started here at this facility, that knew about how to make precision parts and how to fashion different machines, tweak them, remake them, design new machines to make other components and parts affordably. Bicycles were not, people could not afford, the middle class could not afford bicycles back in the 1850s.
Because everything was being handmade,
It was handmade or non-repeatable parts, or they weren't precision enough to be replaceable, right? Interchangeable. So that brought in typewriters, sewing machines. Mr. White had his start here. The White sewing machine was one of the earliest sewing machines. Some of the typewriter companies, same kind of thing. It's just fascinating to me how that system, the American system of manufacturing, impacted the entire world on the affordability of items because the components could be repeatedly made, accurately made in a repeatable, sustainable fashion. That was big. And that's the exciting part.
The entire world. I like that too. Two things as we split off in either direction and continue the conversation. One is, look at this automatic screw machine. According to this, 8,000 to 10,000 screws per day. By 1910, this young man had sold 18 million pocket watches. Did you ever have a pocket watch, Jerry?
I did. As a matter of fact, I still do have one. That was inherited. But when you think about that many screws, and down the road in Waltham, Mass, that's not that far away. And 1871, and you're making little screws by feeding the material in, and they drop them, finished parts in the tray.
I mean, talk about automation and mass production over 100 years ago.
Yeah.
This entire tour is just fascinating. Secondly, you're too young for typewriters, right?
No, I remember in class, I took typing, and I didn't know why, because they told you in college you had to type everything. I remember going from a manual to the introduction to the IBM Selectric typewriter. So I was always the fastest in my class.
Were you?
120 words a minute.
That's fast.
On a typewriter.
Yeah, so speaking of that, if I was to, a young lady, young man out there, if you want to come to the facility here, the museum, and try to type this out, and it's your first time on a typewriter, you might have to put a little bit more finger pressure on a typewriter than you do your cell phone or computer, right?
A little bit, a lot different. Do you look at the difference of the stroke? Actually, this one's not too bad, but if you go too fast, then
that's what used to happen to me. It always gets stuck. It always gets stuck. All right, let's continue the tour. I know this has been long, but I hope you're all enjoying this, because I could be here for 3-4 days and not learn everything I want to learn. We're starting to move a little bit into the modern day world. I see some Haas or Renishaw. I know there's some automation over there with UR and Fanuc as well, but let's just pause real quick, take a look at a couple of these machines before we segue into talking with Joe. I mean, automatic lathe, automatic, I mean, 1903, automatic.
Exactly. And over again, and you just feed in the material, and you come out with a finished part. I mean, and this was the very early 1900s that this was designed by George Gridley.
If I could invite my cameraman as well, just to kind of take a look at some of these tools here. Jerry, I think you're a little younger than me, but I remember working with these hammers. Calipers are very familiar as well. Yep. I mean, I did have a dial on there, but a lot of this is familiar territory.
Very familiar. You're right. The first caliper I used was a dial caliper. Right? It had a big caliper. But I remember using protractors in geometry and
certainly in high school. I didn't know how they worked. I just put a pencil in there and spun it in a circle. Exactly. And I was like, that works, right?
Okay, now what, right? Yeah.
And then I made like 75 more circles and turned it into art.
That's it.
That's what they were using it for, right?
Like we talked, you know, if you're going to make something, you got to be able to measure it and understand. And some of these tools, a lot of these in here were used for measurement. But in the 1880s, a lot of these things were developed. And some of them, to your point, never really changed that much over time. We're making improvements on things that were done before. When I first heard about the American Precision Museum, I thought, all right, this is neat because it's history and it talks about the beginning of really the industry as I know it. But as I came to visit and got more involved and aware of the mission of the museum and what is really happening here, I got more excited because it's more than just a collection of machines. It's a place that really strives to inspire and educate people about manufacturing and precision manufacturing. So when I think about when I was young, things were very different, right? But today's teenagers have access to technology that we don't, right? And when I think about the hours that can be spent on various role-playing games, and you do these things to collect either different weapons or different useful tools, I'm thinking of applying that time towards making not a better mousetrap, but a more, like a less painful hip replacement or a new joint for a knee, and those of us that are, you know, baby boomers, we're going to need some of those joints and other things, and orthopedics is one place you could do it. But you want to have an impact, you can do things, use your creativity and use the knowledge that you have, but make a real difference not only in how people view you, but in their lives and how they live. And to me, that's an exciting opportunity. I think it's really important for those of us that are in manufacturing to try and make sure we raise the awareness of not just the importance of it, but the real opportunity for lucrative, stable careers that pay benefits and pretty good salary and income. But there's an art to some of this, and some of it's science and some of it's technology, but it's important that we hand off to the next generation those tools and the ability to do things, because if it's not born, hatched, or grown, it's made. And if we aren't making things, what value are we adding? And eventually, if nobody's making anything, what do we have? You can't buy it if it's not made. So we need people to do this, and we need to continue that because it's important for our existence, let alone to be able to thrive moving forward. Early on, I wanted to be a broadcaster, right? I did not really envision a career in manufacturing. However, once I got into it, one of the things I love about manufacturing is how all-inclusive it is. And when I think about the number of young women that if they learn a little bit about what it is we do and the opportunities that exist, they can not only thrive, they can surpass some of the men in here, because in my experience, a lot of the young ladies that I've met are more willing to learn and listen because they don't assume they already know everything or whatever. There is no bound, whether it's race or gender or IQ or any of the above, that would limit you in manufacturing. If you're willing to show up, if you're willing to put in a decent effort and do what's asked of you and learn, the opportunities are boundless. We talk about 2.5 million job openings by 2030. The number of openings that are there, the opportunity to grow. There's no glass ceiling, there's no metal ceiling in manufacturing. The sky is the limit. And I feel like I'm an example of that, starting out as an apprentice out of high school to becoming a CEO of a major organization. There are no limits. If I can do it, anybody can do it. Because manufacturing is really the foundation of everything. I remember a president that'll remain nameless that talked about a service economy and this and that, and we don't need manufacturing. We need manufacturing because things have to be made to be able to be used, to be able to be sold. And if we aren't making things, it's just like in life. If you aren't growing, you're dying. If you aren't making things, then what are you providing? You can only turn things over and charge more for it so many times. When you're making something, you're making a difference. And in manufacturing, you can make a substantial difference and you can make a substantial income at the same time. So that's one of the reasons I'm passionate about it.
Very good, Jerry. All right, we're going to talk to Joe a little bit now. I think if we can find him, he's always having
Tony,
a good time in the
thank
shop.
you, my friend.
Jerry, you
Always
are
a
an
pleasure.
absolute pleasure. Now let's jump into a more modern world. Joe, how are we doing today, brother?
Pleased to meet you. Pleased to meet you.
And pleased to meet you as well. Now, a lot of people who are on this tour right now probably hadn't seen the beginning of this, but might be more familiar with the now of this.
Right.
However, we're hoping that there are people outside of manufacturing that are watching this as well and going, well, maybe I want to be a part of it also. So let's take a look at what's happening today.
Absolutely.
Yes.
Absolutely. Here we have a Haas DT1 vertical machining center. In this particular machine, of course, everything that we do here in this innovation station is for show. So if you sit here and you watch me run this, you're going to say, wow, that's really taken a long time.
I could do better. How many of you are going to be, I can do better than that?
Exactly. In fact, in producing these particular products that we make, it's 20 minutes to make one. If I really cleaned it up, I could probably do it in about 6.5.
That sounds about right.
But I'm not using coolant. There's all sorts of different things. We cannot use coolant in this building because we can't afford a coolant leak.
Okay.
It'll end up out in the river, and that would be the end of the museum. Oof. So we use no coolant, only air. It really is not bad because we're only cutting aluminum and brass. But in this particular machine, what we do is we start with an 1.5 inch square aluminum, and we make the widget.
That's very cool. Look at that. All the different shapes too.
Absolutely.
Squares, circles, triangles, and I can't get it out.
It will not come out.
Do I get to take one of these home with me?
You can. Absolutely.
And if you come to the museum, you can take it home with you as well, I think.
Yes, we sell these in our store.
I like it. All right, so CNC, computer numerical control, 3-axis machining here, no
Correct.
Coolant, of course.
No coolant.
We've now evolved from, the middle 1800s to the early 1900s, mother machines making mother machines.
Yes.
Now we have something that's pretty standard in our machine shops. And Joe, let's be honest, between you and me coming from machining backgrounds, as cool as CNC machines are, 5-axis machines, even 8, 9-axis machines, these never leave the shop, do they?
They never do. Every shop that I've ever been associated with or just visited has at least one Bridgeport, if not dozens of them.
Yes.
They are so versatile. They do not have the speed of a full CNC, even though this one has been retrofitted with an Accurite CNC system, all 3-axis. But the ability to do parts that would never fit in that, I can do on this thing, because I can hang parts off the side. So I can do parts this long and put holes in the end. Could never think of doing it in that really nice CNC. So yeah, I love the Bridgeport. I have since I was a kid, first learning how to run these things.
I have a question for you, Joe, since we're here.
Yeah.
If I was to hop on that Haas over there, even with my Mitaco pallet changer, and you were to hop onto this Bridgeport here, and we only had one part to make, and let's not say it's overly complicated, but a competitive one, would you beat me here than I would on the one off there?
No.
You would, the CNC would still win.
CNC is still going to win.
So that goes back to the beginning of this conversation, back with Steve, where this whole evolution has been about time. How much time? The precision was there. The precision was there in the beginning. In fact, in 1851, England was so impressed by it, right? That they wanted the designs of the machines themselves. So it really is about being able to do things faster in a more timely manner, right?
There's one other very important thing, and I point this out to our visitors all the time. The dream of the people that started this business was to take as much of the human interaction out of it. Because the one thing that introduces the most error in anything you do in machining are these things. And with a CNC, especially if you have a CNC with a probe, it takes all human error out of it. It absolutely does.
Joe, I wasn't expecting to have this piece of the conversation, but how many parts or reduced scrap do we have, and we're able to do multiple operations inside of one machine with less hands touching from machine to machine? It makes all the difference, doesn't it?
All the difference in the world. Absolutely all the difference in the world. And of course now we can hold tolerances today that were unthinkable in the past. So, no, nobody could ever do that. No, nobody then could never do that. But we can do it now. And it really is phenomenal how the industry just continues to grow. More innovation all the time. I can't keep up with it. I 46 years as an engineer, and I look at some of the stuff today and go, I'm glad I'm retired.
I look at the stuff today, and my job is to interview people, and I go, I'm glad you know everything, because good grief, I can't keep up either. It is constantly evolving.
It is a lot. And I mean, I have to know all this machinery because I have to explain everything to people when they're coming through.
Right.
And it's been a great experience. It's a wonderful place. You know, I used to look at the ads to come see this place. I never did. Finally, I came here, and now I'm here.
You took a job.
I took a job.
You liked it so much, you stayed.
I retired, and now I'm here. And I just love it. It's
speaking of the evolution, let's slide this way. The evolution of time and having less hands and less operations, we have gotten to a real automated state in our manufacturing, I would say right now, and for multiple reasons. One is because we have to compete on a global level.
Right.
And two, it's safer and it takes away the monotony and the dull. You know, we have the 4 Ds, we're calling it: dull, dirty, dangerous, delicate, is what we're calling it. So you actually have a cell here where you're doing 3D printing, you have a UR cobot, and you actually have a conveyor belt as well. But let me not just forget about this FANUC over here also, but you have an automated cell over here.
Correct. And this is what the whole idea of this was to show people how to take the different technologies and tie them together. These were all separate. Everything was separate. We decided that let's show how the cobot or robots, depending on what you've got in your system, will interact. And what we make is we make these little, and I have to make sure I say it the right way, these are they're not the actual bricks.
Only like. We're not trying to get into trouble.
We're not, and that's why we do imprint AP on here. And it's a neat thing to make. Kids love them, and it takes about 16 minutes to print one up. Table will cool about 5 degrees centigrade. The cobot will come over, pick it up, and drop it into this little bin back there. I've made thousands of them, and we just let it run all day.
So it looks like only one thing's missing here, Joe, and that would be if I wanted to measure my part. Are you going to bring the equator over here from Renishaw and put it as a part of the cell as well?
Well, being that it's 3D printed in PLA plastic, I'll probably just give you a pair of calipers to use.
That works, and I can use the old school ones from right over there as well, right?
It'd be close enough for what we're doing. This over here, you had mentioned the conveyor. This is a separate item over here. And in this particular setup, which I can't run it right now because it's tied in with
and it says, please do not touch.
Please do not touch,
Except
even though I'm touching it. It says do not touch on all these things, and I get to touch them because I have to clean them.
Right.
So all this does is it just picks each one of these up. The conveyor advances them forward, and it puts it in this little tray according to where it should go. And then once that's full, it puts them back on the conveyor, and it will do that all day and all day. And yes, it will do it all night, because one time I forgot to turn it off. I came in the next morning, there were no crashes, it was still going, and that's the advantage of a cobot.
Yeah, dull, dirty, dangerous, delicate.
Yep.
Let it do the monotony.
It does not care.
Yeah.
It does not care. It'll just keep doing it.
Well, Joe, I know you and I can talk about this technology all day.
Okay.
The history has been fascinating. We brought it full circle. The last thing I want to talk to you guys about is what the future of this American manufacturing museum that has everything, I mean, from bridge point number 0 to modern technology right now. Let's go see what the future holds.
The evolution of the reinvention of the American Precision Museum, we're barely out of first gear. We, as a backdrop, have preservation, education, and inspiration as our guideline. Where we're heading from here is to build out the education and prove to ourselves that it makes a difference. We focused on youth and the joy of making things. Youth has not been encouraged to think about manufacturing. And manufacturing is just making things. And kids love to make things. So we're focused on that, and we're taking it to a little higher level by creating STEM kits. We've created a program called STEM plus M Pathways. The M stands for manufacturing. And we're introducing the kids to the idea, this isn't isolated. Yeah, sure, you're making things, you're learning almost a physics lesson, but this all has a reason for being, and it leads to manufacturing. Frequent visitors to the museum include parents with their children. And we want them to leave the museum, get in a car, have the parent look to the back seat and say, well, what did you think? And we want the response to be, wow, we didn't know that you could make things on metal cutting machines. And we just want to make a difference in the way manufacturing and machine tools are perceived. It's scary to think what this country would look like without manufacturing. We began to think we could outsource it around the world. And thankfully it's coming back here. There's been quite an evolution of the support of the museum. I just hope we keep doing the right things, that you'll keep on coming, because I think the more people that understand this message, the more people are going to support us.